Where did the knowledge of building polygonal walls come from? These skills appear suddenly, and just as suddenly, the construction of such walls comes to an end. All that remains are mysterious structures. Let us delve into the origins and look at how it all began. I invite you on a journey back to a time when polygonal walls did not yet exist, and there were only stone screes of the Kachikata quarry. Located on the opposite side of the Urubamba River from the quarry, the Temple of the Sun in Ollantaytambo differs in structure from other polygonal complexes in Peru, and belongs to the category of out-of-class monuments, as discussed in the episode dedicated to the structure of polygonal complexes. It even differs from the nearby Temple of the 10 Niches, which is named after the number of niches in its surviving wall. It is safe to say that originally, there were more than 10. As we discovered in the second episode, a typical complex usually consists of standard elements, terraces, which are stone facings without agricultural function, rock outcrops integrated into the masonry, wall niches, configured rock cuttings on cliffs or boulders, configured voids, configured grottos, water channel networks, as well as tunnels and underground features. It turns out that the Temple of the Sun is no exception, despite its grotesque appearance. Let's take a closer look at its composition. The material used is a volcanic rock, an effusive equivalent of granite called rhyolite. In different sources it's labeled differently. Sometimes I myself refer to it as granite, which isn't technically accurate. The megaliths used in its construction were transported from the Kachikata quarry. This is an extraordinary decision, especially considering that the nearby Temple of the 10 Niches was built from local stone. Such an approach, sourcing material from afar, is unusual for polygonal construction. The fact that the material for the Temple of the Sun was transported from elsewhere points to a significant distinction from the very beginning of construction. Yes, in some cases, certain types of stone were indeed brought from distant sources, but this was rather the exception. This was discussed in more detail in Part 4. Another key feature, the use of megaliths as the primary building element. Yes, nearly every complex includes megaliths or rock outcrops incorporated into the masonry, or even forming parts of the structure itself. But never exclusively megaliths. The zigzags of Sacsayhuaman are indeed impressive in the scale of stones used, but this applies only to the lower row. With each ascending tier, the blocks get smaller, and the remains of the tower show completely unremarkable block sizes. Here, all blocks, both used and unused, are of gigantic size. Once again, we see uniqueness. Now let's take a closer look at the shape of the blocks. They are all close to parallelepipeds. In simpler terms, rectangular in form. Quadrangular masonry is assembled specifically from such blocks. The blocks are relatively small compared to what we see in Ollantaytambo. In all other cases, the mass use of rectangular megalithic blocks is not observed. The already mentioned lower zigzag of Sacsayhuaman is built in the free-form style, see Part 1. So, even at this level, we see a structural discrepancy with other polygonal complexes. There is some resemblance in block size to the Temple of the Three Windows in Machu Picchu, and these parallels are not coincidental. Let's now examine the principles by which the masonry was assembled. Usually, polycurve masonry is constructed based on curvilinear mating surfaces designed to maximize tightness and structural stability. To achieve this, bedding joints are used, the result of carefully profiled interfaces where blocks are locked in place by recesses or protruding key-like elements. Often, a combination of such elements is used. But here, we encounter evidence of metal clamps. Such clamps appear throughout world architecture, from the Americas to Asia. However, in Peru, the use of metal clamps is extremely rare. The only other known sites where clamp traces are found are Urak Rumi and some blocks of Coricancha. In the case of Coricancha, though, they may be the result of later modifications, as the clamp sockets differ in form. But here, in Ollantaytambo, we see clamp sockets not only on individual blocks, but integrated into the masonry. Yet these sockets are missing their corresponding matching part, which means, was the block reused from some earlier structure? And perhaps not just this block? Indeed, clamp marks connecting a stone to empty space are visible on the block just behind the 6 megalith wall, as well as on scattered blocks in front. It's also important to recall that T-shaped clamps are used only in horizontal configurations. Otherwise, they are difficult to pour and cannot be securely fixed. This suggests that the megaliths were originally intended for the assembly of a platform, similar to the one found at Puma Punku. However, such platforms only make sense in areas with unstable ground, where a strong base, something like a slab foundation, is required. But in Ollantaytambo, the bedrock is solid and ideal for construction. There's no need for a platform. In fact, no polygonal complex in Peru uses this type of foundation. Therefore, what was being built was not a platform, but a wall of rectangular blocks held together with clamps, possibly something resembling the wall of 6 megaliths, or the one situated just below it. Now let's turn our attention to nubs. In polygonal masonry, nubs are always located at the bottom of the block. Exceptions are rare, and they are never oriented upwards. Bosses, another element, can be placed anywhere on the block, as discussed in a separate video. But on this block, the nubs are not on the bottom. They are facing upwards. And on other blocks as well, they appear on the sides. This suggests that there had once been some earlier construction, where the nubs were positioned in the usual downward-facing way, possibly with the use of T-shaped clamps? No, that hypothesis is incorrect. The thing is, nubs are a marker of polycurved masonry. They appear only on curvilinear blocks with precision joints, where, during the fitting process, the lower row develops indentations to accept the next stone. This means that initially, some kind of structure was assembled from rectangular blocks joined together with clamps, where instead of nubs, there were large bosses, without any curvilinear fitting. This is also indicated by the fact that many of the blocks have polished faces, which means they were already connected to something, but no traces of joint seating or fitting surfaces remain on them. As a result, we come to a conclusion, supported by multiple data points. A structure was originally erected based on rectangular megaliths, and this structure was later dismantled to build something else. In Inca architecture and construction at Ollantaytambo, Jean-Pierre Protzun pays particular attention to this point. The fact that this structure was not destroyed by cataclysms or explosions but was intentionally dismantled has additional evidence. Many blocks show wedge marks in the form of chips on finely finished surfaces. These chips cannot be the result of accidental damage, as they appear at fairly regular intervals. This kind of damage is typical when wedges are hammered into the joints of a finished structure in order to lift and dislodge a block. Several key points emerge here. First, the scattered blocks have no foundations or remains of associated structures. They cannot be linked to the existing buildings, meaning the dismantling did not occur in the late colonial period. And these blocks are not part of the Temple of the Sun. They are fragments of a structure that existed before the temple was built. Second, during dismantling, no effort was made to preserve the block surfaces, resulting in these chips. This means the polished surfaces were no longer needed. Indeed, when the megaliths were reused, the mating surfaces were reworked entirely, with a layer of stone being removed. This shows that at each stage of construction, the blocks had to be reshaped and refitted. And yet, the fact that the entire work cycle had to be repeated did not discourage the builders. Finally, the dismantling was carried out using primitive methods without the use of any supernatural equipment. This raises a question. Why not use the side recesses to fix levers instead of driving wedges? A simple calculation shows that for a 10-ton block, a wooden beam just 20 centimeters thick would suffice for leverage. But there's not always enough space around the block to use a lever. Not all recesses are deep enough for secure leverage. And for large megaliths, multiple recesses would be required, yet they are always single. This suggests that their primary purpose was not to fix levers. Another detail worth noting is the width of the blocks. For example, on one of the mentioned wall blocks we see a clamp mark, but there is no corresponding socket on the neighboring block. This indicates that the block comes from another dismantled structure. The clamp socket is not centered. Taking into account that clamps must be positioned horizontally, the width of the megalith in comparison with other blocks suggests that this megalith was likely part of the base layer of a wall, with part of it projecting outward. A similar arrangement can be observed in the partner building of the main temple of Machu Picchu, where wide blocks are installed at the base. In the main temple itself, the lower row of blocks also protrudes beyond the wall line. Thus, even in this detail, we see certain parallels between these complexes. Another parallel between the sites is the presence of extended bosses on the megaliths, similar both in form and in style. The block lying in the town below also shows jointing traces. It too was once part of a wall. However, on this one, we see traces of polycurved joints. There are also signs of previous use on the upper blocks of the first megalithic wall. So at least 3 separate construction phases took place, while some blocks were never even delivered to the construction site. Along the path to the top, and in the quarry itself, many blocks still lie abandoned, never transported to the site. These are sometimes called tired stones. Today, they are conveniently used for drying crops, though they also make plowing the fields more difficult. These blocks are definitely not from dismantled structures. There are no signs that they were ever installed into masonry, no polished surfaces, no jointing marks, no nubs, nothing at all. And it would make no sense to drag such massive stones back from a finished structure. In Peru, there is no shortage of building material, and there's no reason to waste effort on enormous boulders when smaller stones would do just as well. On the megaliths, however, there are preliminary processing marks, and these are characteristic for polygonal technology. One megalith shows an attempt to split it using wedges, perhaps to clear a path or for some other reason, but the attempt failed. This work was likely carried out much later, as wedge splitting was not used in the original quarrying and shaping of polygonal blocks. It is remarkable that modern tools failed to break apart what was once not only quarried and transported, but also fitted with such precision. So while construction was ongoing, something was being built and dismantled, yet blocks continued to be transported. This is impossible, not only by our standards but by ancient ones as well. First, a project plan is created. Even the Incas had such plans, and certainly the Greeks and Romans did too. Then, the required amount of building material is estimated. Only after this calculation begins the transportation of materials to the construction site, and only then does building commence. Of course, sometimes adjustments are made during the building process. This is standard practice, especially when visual inspection prompts changes. After all, in ancient times there were no 3D models, so builders had to rely on physical models, or sometimes build almost by eye. However, such corrections usually affect specific areas. The overall design remains unchanged, and especially so for the basic construction principles. Here, however, we observe a complete shift, from flat joints secured with clamps to curvilinear joints with indentations. This is called evolution. And typically such a process takes a long time, entire generations. If faster results are needed, artificially controlled conditions are used. In laboratories and experimental projects, development relies on modeling, where strength limits are tested by gradually increasing the load under controlled conditions, making adjustments after each test. The goal is to simplify the design by reducing size. In Ollantaytambo, however, they worked with megaliths, which does not align with the concept of laboratory modeling. Here, we are dealing with a full-scale project implementation. This suggests that the goal was to develop the optimal construction method best suited for the given natural conditions. But such technical trials require deep knowledge, understanding of processes, resources, and time. When nature itself tests a structure, it takes generations, sometimes even entire epochs. Earthquakes don't happen every day, nor do accumulations of thermal deformation or freeze-thaw cycles. Water seeping into joints and freezing would severely damage dry stone masonry, and this too had to be taken into account. However, this particular problem is not as relevant for Peru's climate. Thus, this may not have been a coincidence, but rather a deliberate choice made by the creators of the polygonal structures. Returning to the realities. Based on the fact that blocks were reused multiple times, and on the signs of evolution in construction methods, we may consider Ollantaytambo as an experimental center, where the origins of Peru's polygonal masonry can be traced. Interestingly, Ollantaytambo was located at the very heart of the Inca Empire's foundation. But to conduct an experiment lasting generations, to verify the correctness of the chosen solution and then apply it on a widespread scale, would require enormous time span. Moreover, in Ollantaytambo we observe deliberate actions, not the gradual architectural evolution that typically accompanies the organic development of society and architecture. Furthermore, architecture reflects the cultural foundation of a society, being both a part of it, its expression, and even its basis. Before any architectural style appears, there are beliefs, religious views, and traditions, all of which also require time, and often span generations or centuries. For example, the Great Pyramids of Egypt were not built overnight. They were preceded by various earlier forms. Not to mention that in the case of Peru, the polygonal standard was never universally adopted. As noted in the earlier parts, each complex has its own unique style, its own architectural solutions, characteristic masonry techniques, and types of stone used. A sudden development of any particular field is usually triggered by cultural exchange, by importing ready-made knowledge from outside. Tiwanaku is often cited as a possible source of inspiration for polygonal construction. However, it is important to remember that about several centuries separate these two historical epochs. Thus, it would have been impossible to directly inherit this expertise. By the time Ollantaytambo was being built, the stone masons of Tiwanaku were long gone. The only option is to reconstruct construction techniques based on the ruins, by studying individual blocks. And indeed, some technical details do match. For example, some blocks at Pumapunku have recesses that are similar to those found on blocks at Ollantaytambo. There are also traces of clamps on the megalithic sandstone platforms. Additionally, there are analogies in the stepped pattern, the so-called Andean cross. However, at Tiwanaku, megaliths were not used. Apart from the gateways, the blocks are several times smaller than those used in the construction of the Temple of the Sun. Moreover, clamps were not used to join the blocks. Instead, the structures were assembled with groove and tongue joints. Tiwanaku's structures represented complex geometric forms, whereas at Ollantaytambo we see simple walls. These differences suggest that what may have been inherited was not the architectural style itself, but only the principles of stone processing and additional reinforcement using clamps. While the function of the clamps, or even the empty recesses left by them, can be fairly easily understood, the stoneworking techniques themselves were lost along with the craftsmen. Accurately reconstructing these methods remains a challenge even today. As demonstrated in a separate video, recreating certain elements is done quite differently from how it was done in antiquity. It is hard to believe that just by observing scattered stones, one could master the art of working them. At first glance, the simplest solution would be to ignore the official dating and suggest that the Temple of the Sun, and thus all other polygonal complexes, were built during the same period as the mysterious Pumapunku structures. But this approach also leads to contradictions. The first contradiction was already mentioned. Polygonal complexes in Pumapunku differ not only in style but in fundamental joining principles. One might assume that specific techniques were developed for Peru, as this region has high seismic activity, while Bolivia's is more moderate. This is exactly what we observe, a transformation of technology from one set of principles to another. But there is another objection, the tool marks on the blocks. Yes, they are similar when comparing the quarries of Cachicata and Sierra Capia. However, the signature is entirely different, just as it differs in Egypt. It is clear that even if the same general method was used, it was applied in different ways, which corresponds more to different cultures. Moreover, in many cases, the Inca cultural layer lies only slightly above the stone chips remaining at the base of the polygonal walls. Thus, even if we shift the construction dates into the pre-Inca period, we still do not end up with a time gap of thousands of years. The idea that the Incas first cleared the area and then settled nearby also does not hold up, because some complexes are located in river valleys, where they would have been buried by sediment to the point of being impossible to discover. As a result, we arrive at a situation where the transfer of certain knowledge and stoneworking methods appears likely, but it is impossible to definitively establish the original source of this knowledge. In all structures that feature precise block fitting, from the Caucasian dolmens and the polygonal walls of Peru, to Pumapunku in Bolivia, Hattusa in Turkey, and the temples of Cambodia and India, one can find certain similarities in stone processing and jointing techniques. For example, characteristic recesses, nubs, or extremely precise fits. However, these similarities concern only the technical aspects of some methods, not the overall architectural concept. Each of these projects is unique in its design, as is the cultural context in which it was created. At the same time, there is an important feature. In these structures, it is difficult to identify any universal or repeating meanings that typically appear in human culture, whether utilitarian, ritual, or religious. In other words, even if there is some shared purpose behind them, it does not belong to the usual system of human everyday or mythological goals. and is therefore difficult to interpret. Nonetheless, it may well be a shared purpose that connects these diverse structures. But what can be confidently stated is that in each region, the construction methods underwent some form of evolution. And Ollantaytambo was such an evolutionary center in Peru. One piece of evidence that suggests Ollantaytambo predated other complexes can be seen in the fact that a block of red rhyolite was found at the base of an opening behind the Temple of the Ten Niches. This point is specifically highlighted by Pratzen in his work. This block is typical of those found above, which means it was likely reused after all phases of the Temple of the Sun's construction were completed. This supports the conclusion that construction using red rhyolite came first. The absence of visible traces of previous use on these blocks can be explained either by their placement, where only certain faces remained visible, or by substantial reworking during resizing. At the same time, it is clear that by this stage the joints were no longer flat contacts but individualized bedding surfaces in the form of recesses carved into the stone. Another argument in favor of Ollantaytambo being the origin of polygonal construction is that many of the blocks have recesses but no nubs. Such recesses are found not only on rose rhyolite blocks, but also on gray rhyolite blocks discovered during archaeological excavations. These blocks with recesses have a rectangular shape and show no traces of polycurve jointing. This suggests that, like the rose rhyolite blocks, they were assembled using flat-fit joints. With this method, recesses were likely used for suspending the block during the fitting process. This eliminated the need for repeated trial placements. The surfaces could simply be gradually brought together. It should be noted that the initial use of T-shaped metal clamps in a zone of high seismic activity was fundamentally flawed. If the objective was to connect the blocks with maximum precision and long-term durability, then clamps of this type would actually produce the opposite effect. When tensile stresses arise, the clamps will either stretch, preventing the blocks from returning to their original positions, or cause the surrounding stone to fracture, with fragments inevitably falling into the joint and locking it open. This sequence of events is completely contrary to the principles of polycurved masonry, where blocks tend to return to their original position due to mating surfaces being shaped to match their equilibrium placement. Thus, the earliest methods used were fundamentally flawed. This lack of foresight deserves separate attention. In total, we can distinguish 5 different stages of construction techniques, though it's important to note that sharp boundaries between them are unlikely. In reality, one method likely overlapped and blended into another. This is supported by previously mentioned evidence. A block with upward-facing nubs of equal size also has a side recess, indicating it was installed using the recess method, which came after the transition to smaller nubs. The fact that all polygonal complexes are diverse, yet all follow the same underlying principle, curvilinear jointing with the presence of nubs, and the absence of direct copying of block shapes, sizes, or bond patterns, speaks to a deep understanding of construction doctrine. It also points to an understanding of how loads are distributed in masonry and how to ensure stability during catastrophic events. This was discussed in more detail in Part 3c. Whoever conducted the experiments at Ollantaytambo learned from them and applied the gained knowledge so effectively that all complexes, except those deliberately dismantled, have survived to this day. However, until now we've only discussed the masonry itself. A polygonal complex consists of multiple components, as detailed in Part 2 of this series. One of the required features is niches, but they are absent in the Temple of the Sun. The Temple of the Ten Niches, on the other hand, built using polycurved masonry, represents a fully realized implementation of tested construction principles. There are no signs of major modification or reconstruction. Its niches are standardized in both proportions and placement. Therefore, the Temple of the Ten Niches cannot be considered an experimental center. It is a mature polygonal complex with nearly all standard components. And this provides chronological evidence. The Temple of the Sun and the Temple of the Condor clearly precede the Temple of the Ten Niches. Further evidence supporting this sequence is a block of red rhyolite placed in a wall opening, the only one among the scattered blocks to be reused in a later polygonal structure. Its form and function fit the intent. It was placed in a deliberate gap between 2 masonry segments, not simply as an entrance, but rather as a purposeful separation of 2 sections using a different material. Returning to the analysis of niches, one might assume that, Since they served a decorative function, they required no testing or experimentation. Such an assumption would be incorrect. Firstly, as discussed in Part 2, their construction follows specific rules, which are consistent across many structures. Secondly, we do find evidence of experimentation, though not in the Temple of the Sun but rather nearby, at the base of the Incamasana cliff. Here, we observe niches composed of two parts, carved into monolithic blocks. These niches were later framed by masonry, with visible joint marks on the upper parts, indicating integration with later construction. In Part 1 of this series, it was noted that this type of niche does not appear in any other polygonal complex, making it a strong argument for considering Incamasana as the second part of the experimental center. Several other features support this idea. For example, the presence of trapezoidal niches carved directly into the rock outcrop is unusual. Typically, niches carved into rock outcrops are rectangular, with minimal or no inclination of the side walls. In contrast, niches built into masonry walls are almost always trapezoidal, with a horizontal to vertical side ratio of approximately 2:1. Some niches carved into natural rock are even square. The niches at Incamasana match the proportions of architectural niches but are isolated, not repeated, again indicating experimentation. Of particular interest is that one niche is placed directly over a crack in the rock, which likely existed before the niche was created. This deliberate placement, aligning geometric forms with natural defects in the stone, even when a slight shift could have avoided the flaw, raises important questions and will be discussed in more detail in a separate section. Another unique feature is the presence of 4 niches arranged in 2 perpendicular pairs. 2 are carved directly into the rock outcrop, and the other 2 are in a block mounted at a right angle to the rock face. Such a configuration is found nowhere else. It's important to note that while polygonal complexes vary in layout, size, stone type, and bonding techniques, and while each complex has its distinctive architectural identity, these variations follow an internal consistency. In other words, once a style is established within a site, it usually applies uniformly to all of its elements, niches, walls, and blocks. At Incamasana, however, we find 3 distinct niche types, all of them unique, and most significantly, non-repeating. This clearly points to a testing phase. But unlike the construction method experiments seen at the Temple of the Sun, here something entirely different was being tested. If niches served purely ritual, decorative, or utilitarian functions, then experimentation wouldn't be necessary. In that case, their size would be determined by practical or cultural factors. To hold ritual objects, everyday items, or simply to meet aesthetic norms or the patron's preferences. Yet the fact that experimentation was carried out suggests that niches themselves may have served a technical purpose. This theory is further supported by a previously noted detail. The bottoms of niches are often uneven while the tops are precisely aligned, a feature that is hard to explain using either practical or aesthetic reasoning. Additionally, it is worth noting that a row of identical niches carved into a single block can also be found at Tiwanaku. In addition to niches, one can observe a large number of G-bosses carved into the rock surface. As explained in Part 3a, these are indeed bosses, not nubs. And again, nowhere else are there so many of them in one place. Creating these bosses would have required considerable effort, as the surrounding stone had to be removed to leave the feature protruding. They are clearly not remnants of connecting bridges that once attached blocks to the bedrock before removal. The topic of quarries was already addressed in Part 1. Incamasana is not a quarry, although it is often mistakenly interpreted as one in the absence of a proper analysis. G-bosses were manufactured in both cylindrical and rectangular forms. At Ollantaytambo, different shapes can sometimes be found side by side, though within a single architectural element. Whether a niche wall or a configured megalith, a consistent type of boss is generally used, not a mixture. Moreover, in finished structures, G-bosses are always arranged systematically, in harmony with the geometry of the structure. At Incamasana, however, their placement appears chaotic, and even when a pattern does emerge, it is often marked by a mix of different forms. This serves as further evidence that we are dealing with an experimental setting. Next, we should note that the rock faces at Incamasana bear a vast number of markings that resemble saw cuts. These markings accompany many of the recesses carved into the stone. Nowhere else can one find such an abundance of traces, especially of this type. In this case, the focus shifts from testing masonry or stone features to testing the tools themselves, along with their methods of application, suitability, and performance characteristics. The sheer number of tool marks, combined with the evident incompleteness of the work, is typical for places where people are learning, rather than simply producing a final result. The key point here is that geometric features in stone, whether niches or complex carvings in finished polygonal complexes, are always completed. Incomplete elements are extremely rare, despite the thousands of total examples observed. This tells us that when these features were created, the work was done with a clear intention to finish, to achieve a specific, meaningful result. These are not quarries, as already noted. The volume of usable stone that can be extracted is minimal, and it would be extremely difficult to obtain large, intact pieces with the complex shapes seen here. Nor can these formations be considered formal training centers for stone carving. In that case, we would expect to find complete yet symbolic compositions rather than what we observe at Incamazana. Numerous incomplete features and intermediary tool marks, which together indicate that this was likely a practice site, a place dedicated to hands-on experimentation and learning. As with the Temple of the Sun, the knowledge gained here later spread throughout the region. And this is not the final argument in favor of the existence of a multi-tiered center for testing polygonal technologies. It is time to return to the topic of the different types of stone used. In Part 4, we specifically highlighted the property of single lithology as a fundamental and defining feature of polygonal complexes. This is not just a technical preference, it is a core principle, a mandatory requirement for the creation of polygonal structures. Violations of this principle were not tolerated. Blocks made of different rock types were used only as rubble or filler, precisely because they differed in mechanical behavior and structural compatibility. But Ollantaytambo contains an unprecedented diversity of lithologies. This includes the already mentioned rhyolite from Cachicata, local rhyolite, and andesite of a different origin, presumably from the Hokoto quarry. Various architectural elements were constructed from distinct rock types, and in some instances these differing materials are placed in direct contact. This is yet another clear sign of systematic experimentation, not with masonry style or tool use, but with the performance characteristics of different stones in real architectural contexts. From a traditional standpoint, transporting rhyolite from Cachicata might be justified by assuming the local gray rhyolite was too fractured or filled with inclusions to provide high-quality blocks. However, the construction of the Temple of the 10 Niches and its terraces, both using local rhyolite, demonstrates that suitable material could in fact be sourced nearby. Moreover, the use of megaliths was not obligatory. Had reducing their size been an option, transporting smaller blocks would have been vastly easier. So the very act of transporting massive stones suggests a deliberate decision, motivated by specific construction goals. It shows that the scale of the blocks was itself part of the design, and that the effort required for moving them was considered acceptable and feasible. All in all, it becomes evident that virtually every aspect of polygonal construction, at least every aspect we can now identify, was studied and tested at Ollantaytambo. The scope of effort is astonishing. Stone had to be moved across rivers and elevation changes, processed multiple times with various jointing strategies, shaped into complex elements, and once certain insights had been achieved, many blocks were simply discarded. Some structures were left incomplete, and unfinished stone configurations remain on site. This is typical of projects abandoned abruptly, but not due to collapse or crisis. Rather, the evidence suggests that the objectives had been met, and what remains is similar to an artist's discarded sketches. Early attempts no longer needed once the final result was achieved. These unused blocks were not abandoned due to natural disasters or mystical events. They were simply no longer required. Even while new buildings were constructed nearby, including the Temple of the 10 Niches and rough masonry structures, these large, mismatched stones were left behind. Why? Because they were of a different lithology and therefore unsuitable for polygonal construction. Some have shallow recesses, suggesting they belong to the earliest phases, when joints were flat, not polycurved. Indeed, most of these blocks lack the defining features of polygonal fitting. No complex interlocking profiles, no bedding joints, no characteristic nubs. Could it be that those who built with rough stone nearby simply weren't capable of handling blocks of such size? Unlikely, the blocks are not that large. Perhaps these stones were considered sacred? Their workmanship truly is impressive, enough to inspire if not awe, then at least respect. Maybe blocks with such perceived spiritual significance were forbidden from being used for utilitarian purposes. Also, unlikely. There are countless examples where individual polygonal blocks were incorporated into rough stone buildings, just as surviving segments of polygonal masonry were reused. It's more probable that the builders of the simpler structures nearby were completely unaware of the existence of these blocks, simply because they were buried beneath a layer of soil, even if not a particularly thick one. Now, let us recall the rhyolite megaliths left behind in the quarry. We finally have an explanation for them. There was no need for a strict architectural project. What was needed was simply a sufficient number of blocks for experimental construction, where the exact required number was unknown in advance. In such cases, materials are prepared with a surplus, so as not to waste time later in the event of a shortage. From a conventional perspective, polygonal construction was just beginning to develop, so all blocks should have eventually been used. But the fact that many remained in the quarry suggests that they were no longer needed. The objective had been fulfilled, and the excess materials were abandoned. This, in turn, may offer an answer to the mystery of the so-called tired stones, the blocks left lying unused. In reality, it's not possible to conclusively link the numerous experimental structures assembled near the Temple of the Sun to the abandoned megaliths. This assumption is based on the number of ramps, each seemingly tailored to a specific block. But these ramps exist in roughly the same number as the tired stones, while the total number of megaliths is far greater. Even if ramps were reused between blocks, we would expect to see short branches or spurs, dozens of them. But they are not present. It's doubtful that ramps were dismantled each time, since many of the central ramp structures remain intact, and we would expect those to be removed as well after transporting a block. If this had been standard practice, this leads to the reasonable hypothesis that some megaliths were successfully transported without ramps, or with only minimal ramp infrastructure, while others were transported later but never reached their intended destination. In the end, there is no real reason to deny Inca authorship of these works, but that's not the main point. What matters is that certain changes occurred, which led to the abandonment of stones and the inability to continue transporting them, despite the fact that earlier transportation had been successful. Let's now take a closer look at the final result of the experiment. Unfortunately, reconstructing earlier phases of the process is no longer possible. This would require 3D scanning of all blocks that show traces of tie rods, followed by an attempt to recreate at least part of the original structure. Still, I'm fairly confident that what we are looking at is nothing more than a segment of a wall, and that would have been enough for the purpose of testing the method. From the outset, the goal was likely not to build something monumental, but to construct critical fragments, perhaps even just a single wall, rather than an entire building. This conclusion is further supported by the fact that the final construction attempt likewise did not result in any fully realized structures. Instead, what we observe can best be described as a collection of core elements of a polygonal complex. Specifically, we find two megalithic walls, backed by smaller blocks made of a different rock type. We've already encountered points of contact between stones of different lithologies, a recurring feature across many complexes where an outcrop of one type of stone is clad in masonry made from another. In this case, the megaliths are so tightly joined that they can be perceived as a single unit, a synthetic outcrop. What we have, essentially, is a rose rhyolite core, clad in local gray rhyolite masonry, an artificial version of a geological interface. To the side of the 6 megaliths, we see a block with prominent protrusions, indicating it had previously been part of some earlier construction. The nubs are symmetrical, uniform in type, and large in size, suggesting they belong to a transitional phase, somewhere between flat surface jointing and polycurved masonry. There are also recesses along the lateral faces of this block. Researcher Protson once suggested that this block might be a draft element for an entranceway. However, this interpretation seems unlikely. If the protrusions were meant to be used as a threshold, their orientation and form do not match any known threshold types. Lintels tend to have simpler designs, and the direction of the protrusions does not correspond. It is more plausible that this megalith was reused to create geometric cutouts. Similar recesses can be found on another block nearby, a rather distinctive form, resembling a double-seated chair. Thus, these components of a polygonal complex are present here as well, but in minimal quantities. Usually, they are far more numerous. They often occupy a central position, forming an organized system of geometric shapes that somewhat resemble acoustic devices. Apparently, near the Temple of the Sun, only a few examples were deemed sufficient. In Machu Picchu, the number of such geometric stone forms is also limited. It should be noted that such groupings are found only in limestone. In most cases, with granite, diorite, or andesite, geometric recesses are rare. However, this cannot be attributed to the difficulty of working with harder stone. For example, in Urak Rumi, where the rock is granite, such formations occupy a central position. Every polygonal complex contains hydraulic elements, channels, and waterfalls. They are present here as well, though unfortunately not preserved in full. Only some elements remain: sections of water channels and a few waterfalls, all made from local stone. Normally, waterfalls are located directly adjacent to polygonal structures with niches or just downstream from them. Here they are located higher up, among constructions made of rough stone. This suggests that some structures were dismantled. Most likely, the rectangular blocks with recesses mentioned earlier belong to them. The fact that the blocks are not scattered randomly but arranged in rows, which is how they were discovered, indicates intentional disassembly rather than the result of a natural or social catastrophe. The question of why some structures were dismantled while others remained has several possible explanations, which we will return to in later videos. From the remains of the water channel carved into the rock, we can see that, just like in Machu Picchu, the water flow turned sharply to the side, yet another similarity. Polygonal terraces, more precisely, rows of stone facings without any agricultural purpose, are a consistent feature of polygonal complexes. They are present here as well. Their appearance is highly unusual. A cellular structure consisting of facing stones connected to the bedrock with masonry buttresses. This execution style is not found anywhere else, which, by now, is to be expected. Some sections of terraces in Machu Picchu have a similar structure, but they are built of rough stone without the use of polygonal technology. In the nearby Temple of the Ten Niches, the terraces are of a standard type, long stretches of facing with a minimum of buttresses. Notably, the masonry is done in a polycurve style, using local stone. And since polycurve block joining developed after flat jointing, this indicates that the terraces were constructed after the main structures. Perhaps they were not initially planned, but something prompted their addition. The complex structure was likely intended to provide additional reinforcement on the steep slope. It may also reflect a process of gradual building, continued until the form satisfied the creators. Upon closer inspection, one can see variations between different sections of the masonry, not only in block size but also in style, which may suggest a staged construction process. In the second part of the series, the Temple of the Sun at Ollantaytambo was presented as a complex beyond classification, due to the presence of unconventional elements, and indeed, that is the case. Virtually every structure within it has a unique appearance. Therefore, Ollantaytambo represents a one-of-a-kind location where construction methods were tested and refined. Various stages of polygonal technology were implemented here in succession, from rectangular blocks joined with T-shaped clamps to highly precise polycurved masonry. A key element linking these phases of experimentation is in Kamisana, a second type of testing center, where the focus shifted from masonry techniques to tools and methods of stone shaping. The knowledge gained here extended beyond methods of assembly. It also encompassed technical aspects, such as the creation and form of niches, the interface of different rock types, multi-layered facings, and hydraulic systems. The results achieved at Ollantaytambo did not become a model for direct replication. polygonal complexes across Peru retained their individuality. While the underlying method of curve jointing remained consistent, each location developed its own approach, particularly in second-type elements such as niches, terraces, and geometric recesses. This suggests that the testing process may have extended beyond architecture into other, as yet not fully understood, functional purposes. In the following parts of this series, other polygonal sites will be explored, with the observations and conclusions drawn from Ollantaytambo, serving as a methodological foundation for further analysis. Thank you for watching and subscribing. See you next time.